Speed is a scalar quantity and it answers the question of how much. It's one-dimensional, and the way you figure it out is you measure an object that's moving and then you figure out how far the object went, or the distance, and you divide that by the time. So the formula for speed is distance divided by time. In physics class, you'll often use meters per second, but in your car it's miles per hour or kilometers per hour. And to find the average speed, you want to measure the total distance something traveled. So if it traveled 5 meters and it took 5 seconds, you would then plot that point, draw the line, and you've just graphed, the slope of this line is the speed. And when you have a straight line on a distance versus time graph, you have a consistent speed. The next concept is velocity, and velocity is a vector quantity. It's two-dimensional, and it has a direction and a magnitude. So you can say how much and which way. So in this case, you could measure the distance in time, and you know that it went that way. So once again, you could measure how many meters it traveled and time how many seconds, find the points, and connect them. And with velocity on a distance versus time graph, once again, if you have a straight line, that means it has a constant velocity. Acceleration is the next concept, and it is a vector quantity as well, meaning it has a direction and a magnitude. And one way to think of acceleration is change in velocity. So if you have a change in velocity, you have acceleration. I like to think of the metaphor of a car. So if you have a car, this is kind of a bad car, sorry about that. If you have a car and it's driving down the road, it's going this way, and let's say it's going 10 meters per second in that direction. There's really 3 ways you could accelerate the car or change its velocity. You could press the gas pedal, sometimes called the accelerator, and it would go fast, and that would change the magnitude of the velocity. You could hit the brake pedal, which would slow it down, and that would change the magnitude of velocity. Or you could turn the steering wheel, and that would change the direction of the velocity. All 3 of those things would create acceleration, or a change in the velocity of the car. So here we have that ball moving across the bottom again, except this time it's sped up a little bit, it reached a constant speed, and it slowed down. So if you have an object like that, and we go to the distance versus time graph, it's going to look a little different. If you have a change in speed, remember, constant speed is a straight line, but if you have a change in speed or velocity, a positive change would curve this way. Then if it slows down, it would curve the opposite way, and if it came to a stop, it would look like that. If we get over to this graph, we're graphing velocity versus time. Now this slope is the y-axis value, and that will look a little different. So if you have increasing velocity, you have a line going this way, and then if that velocity becomes somewhat constant, it looks this way, and then if you have the velocity dropping off, it would go back that way, and eventually, if it stops moving, it would hit here, which is 0 velocity. Hope that was helpful. Thanks for watching.